Okay, good morning, guys. Just wanted to start with the land acknowledgement, as we do every morning. We acknowledge we are hosted on the lands of Mississauga of the Haudenosaunee, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit people. Okay, so today, I know it hasn't started yet, but it is. So we know this is a pre-recorded because I will not be able to be live today. So in the announcement, which when you guys will see in the morning, it will show that I will be posting a pre-recorded over here, but fast forward because you guys will be watching this video anyways. So what we're going to be talking about today is the inverse of a function and simplifying polynomials, okay? And then there'll also be a quiz on the above, just like yesterday, that will be due Tuesday before 11:59 p.m., okay? And all the quizzes, that's why it's important to do the worksheets, because all the quizzes, you only get one attempt, okay? And just like yesterday, it was like 3 questions. So if you get all 3 questions right, you get 100%. If you get 1 question wrong, you get 67%. That's why it's very important to do the worksheets, okay, that I will be posting. So let me come out of this and let's go into content so we can look at the first lesson for today, which is the inverse of a function. So I'm going to go and turn this into student view so you guys, I can see what you guys will be able to see. So there's no mistakes there. Okay, so now I'm going to go to content. And under content, functions. So we did this yesterday, lesson 1, we did yesterday. Now we're going to go in, and we did lesson 2 yesterday. And now we're going to lesson 3, which is the inverse of a function. So you can see that. So I'm going to click on that. So here would be the lesson documentation, which basically talks about inverse of a function. But what I'm going to do is I'm going to play the video and we'll watch the video together, and I'll stop at points where there's an emphasis, and then we'll go through that emphasis part. Okay, so here we go.
Last lesson for the transformations unit. It's the last kind of type of transformation. So we've looked at horizontal stretching, compressing, vertical stretching, compressing, shift.
Just give me a moment, guys. I want to make sure.
Light left.
Just making sure that everything is okay. Okay. I'm just going to stop it for a second. I want to make sure that the audio is being recorded. Yeah, it looks like it's covering the audio. Okay. Okay, so we got the audio being covered. So here we go. And we're going to go through this lesson, which is the inverse of a function.
Right, up, down. We've also looked at something called a vertical and horizontal reflection. The inverse of a function is actually kind of like a diagonal reflection. It's going to be reflecting across the line y equals x instead of across the x or y axis. Like a vertical or horizontal reflection, we're going to be reflecting across the line y equals x. So inverse of a function, we have a notation to indicate that we're finding or have the inverse of a function. And the notation is this f with this thing. It looks like an exponent of -1, but it's actually just notation. It's not an exponent. to get the inverse of a function to reflect it diagonally across y equals x, all we have to do is essentially switch the x and y coordinates with each other. So if f at 5 equals 13 for the inverse of the function, so that's what this little notation here, that -1, that tells us we have the inverse. For the inverse, f at 13 would be equal to 5. So
Okay, let's just pause there and let's just see what he means by that. So I'm going to write on the screen here. Hopefully I can get that going. So normally, right, when we see this, we're saying this, okay, f of x, or sorry, f of 5, hopefully this can start writing properly, f of 5. If I'm going to have a problem with this, is not going to be good. So f of 5 is equal to 13. Remember, we can say f of 5 is equal to 13, right? Or we can say and then f of 5 is basically saying that's the function of, this can be replaced by y, okay? And then we can say y is equal to 13. And basically what we're doing is, let me just erase that because I think I screwed up a little bit. But basically what we're saying is f of x, okay, is going to equal to whatever, in this case, it is 13. But what we're saying is when we're doing the inverse, right, whatever y is, the value of y and x switch, okay? So you can see here, that would be x over here, and then over here, okay, my marker's not working. Over here, it becomes the y, okay? Inside, and then over here, this was the y. Maybe this is better, and this is now the x over here. So it's going to be more clear as we go, as we continue. I just wanted to just pause there and just say that we're flipping the x and y values in order to get the inverse, like it says there. Okay, inverse of functions are all more input. Basically, x and y's are reversed. Okay.
here we have the point 5 comma 13. That's what that tells us for f at x when x is 5, y is 13. But for the inverse of f at x when x is 13, y is 5. So all that's happened is the x and y coordinates have just swapped with each other. So the inverse of a function has all the same points as the original, except the x's and y's have been switched with each other or reversed. If we're actually going to draw the inverse of a function, all we need to do is have the points for the original function and then swap the x's and y's with each other, and then we can plot those, and we have the graph of the inverse of the function, and it's going to look like it's just been reflected diagonally across the line y equals x. So let's actually do a question where we find the inverse of the function g at x. So g at x is equal to this transformed version of, it looks like our parent function is root x. So I'm going to, since this square root here, that tells us that our parent function, I'm going to call the parent function f at x. The parent function is root x, so we'll have to remember what that looks like. We'll have to apply the transformations to that parent function using our a, k, and c values to get the points for our transformed function g at x. And then we don't want to graph g at x, or we do want to graph g at x, but our end goal is not only to graph g at x, but we also want to graph this, the inverse of g at x. And remember, this exponent, or it's not an exponent, it's a notation. This -1 is not an exponent. It's just a notation telling us it's the inverse of g at x, which means we just take all our x and y coordinates from g at x, and we switch them all with each other, and we will get the coordinates for the inverse of g at x. And I think on this page over here, I forgot to scroll down, but I actually made a note here. And important to note, inverse of f at x, this -1 here, it's read as the inverse of f at x, not f to the exponent of -1. This -1 does not behave like an exponent. This does not mean 1 over f of x. It doesn't act like an exponent. It just means the inverse of f of x. Let's get back to this example. So first, key points to the parent function root x. Hopefully you remember I chose perfect square x values so that we can get integer values for y. Square root each of those, 0, 1, 2, 3. That's what the parent function root x will look
Okay, so what you chose there, you chose easy numbers, right? So I plug in 0, square root of 0 is going to be 0, square root of 1 is 1, and square root of 2, square root of 4 is 2, square root of 9 is 3. So you put easy numbers in there to get this chart, okay? So now he's going to go from there to do the transformation of it.
look like. Well, what would the transformed function g at x look like? Okay, well, let's start with the horizontal transformations. K is -1/2. So first of all, that's going to be a horizontal reflection because it's negative. So the x's are going to have to be multiplied by a negative value to change the sign of them. And the k value, we always have to flip it. So we have to do 1 over 1/2, which gives us 2. So it's going to be a horizontal stretch by a factor of 2. So we'd have to multiply the x's by 2. Combine those two things, multiply the x's by -2. That's the only horizontal transformation. Vertical transformation, right? So this was our k, this is a, this is c. A and c both are vertical transformations. A -2 vertically stretch by a factor of 2 and vertically reflect. So I'd have to multiply the y's by -2. C value of 3, that means shift it up 3. So I'll apply these transformations to the points of the parent function and get the image points for the function g at x.
Okay, I'm pausing here because he's talking about A, K, and C. You would have known what these transformations were if you did it in grade 10. So as he's talking about this, there's probably a good chance you don't know why is he calling this A, why is he calling this K and C? There's a good chance you don't know, right? So I understand that. So the important thing is, in this case, he's trying to graph this and he needs these values. Going forward, you probably won't have to know that you won't probably need to do this right now because you need to have a better understanding. But when you are trying to graph this, if I get the transformation version of the parent version, and then if I want to figure out what is the inverse, which is this function over here, basically what I have to do is just reverse these numbers. So he's getting these numbers here. So when I go to G inverse G of X, it's going to be easy. So he's trying to figure this one out. So this can be flipped. That's all. Okay. And algebraically, if we wanted to just basically, we could have just looked at this equation, forget about A, K, C, and we could have just swapped y and x, and then basically we would isolate the new value of x. Okay, that's what we would be doing. But I think that's going to come up later on as when we do an example. Okay, hopefully that makes sense. So again, he's just figuring out how to plot this, what the values are, and then he's going to swap it over here.
So multiply the x's by -2. There are my x values. The
okay,
y.
So again, he figured this -2, he's going to multiply all the x's by -2. So all these values here were multiplied by -2. So 0 times -2 is still 0. -2 times 1 is -2, and so on. Okay.
Y's, also multiply them by -2, but then add 3.
So now what he's doing over here is basically multiplying all the y's by -2 and then add 3 like it says up here. Okay. So -2 times 0 is still 0, but add 3 is 3. So -2 times 1 is -2 plus 3. Okay, so plus 3, that would make it 1.
So 2 times -2 is -4, plus 3 is -1. 3 times -2 is -6, plus 3 is -3. There's the points for the function g at x. Let's start by, actually, let's graph g at x. So plot the point. Oh, and notice I made my scale go by 2's so that I could actually fit these points onto the graph. So the point 0, 3 would be right here. The point -2, 1 would be right here. the point -8, -1, -8, -1 would be right here. And the point -18, -3, 10, 12, 14, 16, 18, -3 would be right here. So remember the parent function root x, just roughly, it looks, well, not quite like that, more like this. That's what root x looks like, like curved looking. It only exists to the right. To the right of the line, x equals 0, right? Because we can't square root a negative number. But keep in mind our transform function, it's been horizontally and vertically reflected. So instead of continuing up to the right, it's going to be flipped vertically and horizontally. So it's only going to be continuing, oops, and I should do this in blue, down to the left. I didn't connect those very well, but you can imagine me going through those points with a smooth curve. I'll try and do it a bit better. Continuing in the downward to the left direction. So that's what our function g at x looks like. If we want the function inverse g at x, what we have to do is we have to take all of these points and just swap the x's and the y's with each other. So instead of 0, 3, we'll use the point 3, 0.
Now you see how easy that was? He's just swapping, right? So we already have the value of x is 0, and then y is 3. So when you swap it, now it'll be 3, 0, 1 and -2, -1 and -8, and then -3 and -18. So that's why he did this first. Now he can figure out what the values are for the inverse, which is swapping x and y.
So 3, 0, 1, -2, -1, -8, -3, -18. So I just kept all these same points, just swapped the x's and the y's with each other.
And now he's going to plot this, and this would be the inverse of this. So he's going to show it right now.
So if I plot those points, 3, 0, 1, -2, so 1, -2, -1, -8, so -1, -8, whoops, wrong way, and -3, -18. I believe that's 19, 10, 12, 14, 16, yeah. I would get this function.
Okay, I'm going to pause there. So this is basically a mirror of this. So if I were to draw a line, so you can kind of see what I mean. So I froze the screen so we can actually probably get a line here to make it look like it's, so you can see the actual, so the line, the mirror line would be like this. So that's the mirror line, okay? So I'm just trying to get it exact. So that's the mirror line. So you can see here that g of x, when you get the inverse, which is mirrored, it looks like this. The inverse is like this. And this line here, this line that you see over here, that line is called y is equal to x. Okay, so you can see there, right? So if y is 1, x is 1. If y is 4, x is 4. So this is why we call this line. And this is the mirror line. So you can see how it's equal distance, right, from this line. So this distance from here, that point to that line, is the same as that distance from that point to that line. You can see the distance from this point to here is the same as this distance from this point to here. That's what we call it, the mirror line, okay? And then with the mirror line, the inverse of a function goes around the mirror line, okay? So I just wanted to show you that while I had the screen frozen there.
And notice this is our transform function. Sorry, this is the inverse of our transform function g at x. So the inverse of g at x looks like this. And hopefully you noticed this looks like it was a diagonal reflection through the line y equals x. So if I drew the line y equals x,
Yeah. So you can see
it would look like
he's drawing a line which will
this.
what I was showing you. This is actually a little bit off
And
there.
notice
He's a
the
little bit
inverse
off.
of g at x. Oops, let me fix
Maybe he'll
that.
fix it. Looks like
The
it's
inverse of g at x is just a reflection across this line. Each point has just been reflected across the line y equals x. So that's how we graph g at x and its inverse.
okay. So like I was saying here, this is a line called y is equal to x, and I drew it earlier, so you can see that's the mirror. Okay. So this is so if you were given a graph of say a regular function and it's saying get the inverse of it, you can just basically get points and say, well, the distance from here to here, perpendicular distance. Well, if I know that distance, then I know for the inverse distance would be over here, right? So you can kind of do that if you're given a graph, right? And so on. Or say it's a multiple choice question, and I have the original function here, and then it's saying which one of these other functions is the inverse of the original function. Well, you can tell if it's mirrored across this line here. You can tell. If it isn't, then it's not an inverse function. Okay.
Find the key points for g at x by doing the transformations necessary. Swap all the x's and y's with each other, and we get the graph of the inverse of g at x. Make sure you label them both properly. Next thing I want to do is I want to look at, okay, we can make the graph of the inverse, but what if I wanted to write the equation of this inverse function? So I want to write the equation of the inverse of this. Here's what we're going to have to do to write the equation algebraic.
Okay, so the equation part is the part that's more important because, I mean, a lot of times you're not going to be doing the graph. You're going to be doing, I give you the original function and then give me the inverse equation function. Okay, so that's where you need to follow this. So here, you replace the f of x with y, then you're going to swap the x and y variables. And then once you swap the x and y variables, then you isolate your y. And then once you get the y isolated, then you replace the y with inverse function notation over here. Okay, so watch. Here's an example.
So first of all, replace f at x with y, right? F at x means y. And then for an inverse function, the x and the y switch with each other. So in the equation, we do that exact thing, switch the x and the y variables with each other, and then rearrange the equation to isolate for y. So here's what it looks like. So replace g at x with y. So y equals 3 at x over 4. Inverse functions, the x's and the y coordinates switch with each other.
Okay, so basically you're going to see what he's going to do here. Let me see if I can maybe do some of this too. So replace the g of x with y. So now what you do, you're going to swap the x and y. So now that I'm going to have the x over here. Okay, come on, pen please, work. Okay, so x is over here, and then the y is over there. So it's going to be 3y over 4. So now once I have this, I have to isolate. Okay, I have to isolate the y. How do I isolate the y? Well, I don't have much space here, so I'm just going to go over here and finish it off over here. So I've removed the 4, bring it over to that side. It's going to be 4x is equal to 3y. If you guys see how I did that, right? If I'm dividing by 4, I bring it over to the side, I multiply by 4. Okay, so now if I want to get rid of the 3's, I still need to isolate the y. So I'm going to divide by 3, move this 3 over to this, and divide by 3. So it's going to be 4x divided by 3 is equal to y. I can just replace, swap positions. So it's going to be y is equal to 4x over, come on, pen, over 3. Now what I do is replace this y with the inverse notation. So it's going to be G inverse X is equal to 4X over 3. So that's the inverse, okay? That's the inverse of that function, okay? So that's what he's going to do. So let's just watch the example.
So we'll do that in the equation. Instead of writing y, we'll write x. Instead of writing x, we'll write y. And now we just rearrange this equation algebraically to isolate y. So multiply the 4 over, and then divide the 3. And then lastly, we'll write the proper notation. Instead of writing y, we will write the inverse of g at x. Right? We no longer have g at x, we have now the inverse of g at x. It's equal to 4x over 3. So that one's done. This one, function is h at x. Let's write the equation algebraically of the inverse of h at x. So we start, replace h at x with y.
Okay, so same kind of thing. Okay, I'm just going to slow it down so we can all see it again. Okay, so what he's going to do, we're going to basically replace the h of x with y, which that's what he did there. So you would have, let me just finish it off, use blue. So I'm following him. So here you got 4x plus 3, okay? Now I'm going to swap the y and the x positions. So x is now going to be over here. And the y is going to be beside the 4 plus 3, okay? And now I'm going to try to isolate for the y. So I'm going to bring this 3 over to that side. It's a plus 3, it's going to go that side. It's going to be a negative 3. So x minus 3 is equal to 4y. Now I want to get rid of this 4. That means I have to divide, bring it to that. So I'm going to divide this whole side by 4. So it's going to be x minus 3 divided by 4 is equal to y. And I can just, just write it the other way around because we always like to have the variable on the left side. So y is equal to x minus 3 divided by 4. And we write it with the inverse. And then it's going to be x minus 3 over 4. Okay. So that would be the answer. Okay. So let me play the video and then we'll continue. Let me just move this. Just want to just move this over to the side here. So I can kind of keep that while he's solving it.
Swap the x and the y with each other, so x equals 4y plus 3. And now rearrange the equation to isolate the y. So move the 3 over. So x minus 3 equals 4y. And then divide the 4. And then now that it's rearranged to isolate y, we replace y with the notation for the inverse of h at x. So inverse of h at x equals x minus 3 all over 4.
Okay, so you see, so it's not that hard when you just do that. Okay, when you follow those steps, it's not hard.
I don't know if we need to I don't think we need to do that example. That's similar to what we already did. But C, so f at x, let's write the equation inverse of f at x first by changing it to y. And I swap the x and y, y squared minus 1. Move the so now we want to isolate y. So x plus 1 equals y squared. And then to move the squared over, we have to square root, but then don't forget we have to consider both possible answers for the square root of x plus 1, the positive and the negative, or else we would only get half of the graph for the inverse of the function. And now that y is isolated, we can go ahead and replace that with the symbol for inverse of f at x equals plus or minus the square root x plus 1. Let's do last example for this one. We'll when we have a quadratic written in standard form, to be able to write the equation of the inverse, first thing you're gonna have to do is convert it to vertex form. Well, first change f of x to y. So y equals 2x squared plus 16x plus 29. Notice that there's two x's in the equation and one of them is squared, so we can't collect. So what we're going to have to do is we're going to transfer this to vertex form by completing the square. So
Okay, so this is a new thing. Maybe it's not a new thing, but hopefully you guys learned this in grade 10, is when you're trying to go from the vertex form, standard form to vertex form, you have to go through the process of completing the square. Okay, so he's going to show you that process of completing the square. So now watch.
hopefully you remember how to complete the square. 2x squared plus 16x goes in brackets.
Okay, so, okay, let's continue. So basically, the first two terms are going to be tied together, and then the last term is going to be outside of the bracket. Okay, so now with the first two terms, he's going to complete the square.
Plus 29 off the end, factor out just the 2.
So in order to also complete the square, you need to have no number in front of the x. So there's a 2 there. He takes the 2 out of the bracket. So if that's the case, then inside the bracket, you're going to have x squared plus 8x. Okay.
From the first two terms, x squared plus 8x plus 29. Add and
Okay, so now once you take out the 2, now you can complete the square. So you're going to have, basically you're going to divide the second term by 2. So if you divide 8 by 2 is 4, and then you square it. So 4 squared is 16. So you're going to have plus 16, and then you're going to have minus 16, okay? And that would be completing the square.
Subtract half of the 8 squared to get us a perfect square trinomial in the brackets. So half of it is 4, squared is 16.
Okay, so you have to, so the reason why you add 16 and then you subtract 16, because remember, it's an equation, it has to balance. I can't just add in 16 and then that's it. No, I have to balance it out by subtracting a 16. But because I'm going to do some math, I call it math trickery, you can take that minus 16 outside the brackets and it doesn't affect the overall equation. Just watch.
Add and subtract 16. And then we take the negative.
Yeah, so now the negative 16 is going to come out of the bracket, but if it comes out of the bracket, I have to multiply by 2. So it's going to be out of the bracket, I multiply by 2, it's going to be negative 32 outside the brackets.
16 out of the brackets, so that all we're left with is a perfect square trinomial in the brackets. Take it out by multiplying it by the 2 that's out front. It gives us negative 32.
Okay, now this here, this perfect square that you have inside this bracket now. So we know that two numbers that multiply to give you 16 and the two numbers that add together give you 8. Well, that's going to be 4, right? So your next line is going to be y is equal to 2 bracket x plus 4 squared. So that's basically completing the square. And then the outside, you're going to have 32 minus 32 plus 29. So it's going to be minus 3 over here. Okay.
Plus 29. Inside the brackets, we have a quadratic. It's a perfect square trinomial. If we find the numbers that multiply to 16, add to 8, it's 4 and 4. So we could factor x plus 4 times x plus 4, which is x plus 4 squared.
There you go. That's the answer.
Negative 32 plus 29 is negative 3. Here's our quadratic.
Yeah, so now here is the quadratic that is in vertex form. So what does that mean? I know that, well, I have a 2, so that's going to stretch my parabola. When we say quadratic, that means we're talking about a parabola. It's going to stretch my parabola, but my starting point on the graph is going to be at -4 and -3. So what does that look like? What do I mean by that? Well, if I'm drawing a graph over here, the parabola would start at -4 on the x and -3 on the y. So it'd be down here somewhere. And then it would look something like this. Okay, something like that. Okay, that point is -4 and -3. Okay, that would be your vertex.
It's now in vertex form. So now what we can do is swap the x's and y's with each other. So what we did up till now is complete the square. Now we'll go through the process of writing the equation of the inverse of the function by swapping.
Okay, so now you swap the x and y. So x is going to be out here and y is going to be inside the bracket, right? And then you go through the process of isolating y. A little bit difficult because now y is inside a bracket and then there's a squared. So when you do isolate the y, you're probably going to have a square root. You will have a square root because you have to get it outside of this bracket now. So here we go.
X and y. So x equals 2 y plus 4 squared minus 3. Now we'll isolate the y, move the minus 3 over, we get x plus 3. We'll also have to divide the 2.
Okay, so you see how you got that? So this 2, first of all, that 3 went over to the other side and became x plus 3. Now then this overall x plus 3, I had to divide it by 2 because I bring that 2 over to that side and divide it by 2. So now this x plus 3 divided by 2. So I'm left with just y's bracket y plus 4 squared. So I'm also going to have to move this squared over to that side and it's going to become a square root. Okay.
And now I'm going to have to move the squared over. And remember from before, we're going to have to consider the plus and the minus, both options.
You got to remember that when you're doing a square root, you have to consider both options like you said there. So now it's going to be, under the square root, it's going to be x plus 3 divided by 2. And then it's going to equal to y plus 4. And then you can isolate the y by bringing the 4 over to the side, and it's going to be a minus 4. But it's not going to be inside the square root. It's going to be outside.
Square root this so that we get the entire function and not just half of it. And then lastly, you'll move that plus 4 to the other side. Becomes a minus 4. I'm going to put it in front. So negative 4 plus or minus the square root of x plus 3.
Now he put it in front because it's probably safer to put it in front. If you put it behind, it may be confusing. Someone may think, well, that negative 4 is inside the square root. No, it's not. So you put it in front. So there's a clear showing that it's not part of the square root. Okay.
Over 2 is equal to y. Y is now by itself. So I can write the inverse notation, inverse of f at x. So that was just gone through really quickly, how we can algebraically write the equation of the inverse of a function.
Okay, so that is done. So, you're going to have a worksheet related to this. So let me just come out of this. And here is the worksheet. You click on that. You can do the practice worksheets on doing inverse of a function. Now we're going to go into simplifying polynomials. So there's so many variations of how to simplify it, right? So that is a big, a variety of different ways, okay? So I'm gonna go through this. There's a video. If I show you here, where is the video? Over here on this page here, there is a bunch of videos to go through. I don't want to go through them. I think you can go through them, but I label them here. If I want to add abstract polynomials, I can check that video. If I want to multiply polynomials using a FOIL method, I can check this video. And then this video, if I want to do common factoring, I can check this video. Factoring simple trinomials, check this video. Complex trinomials, check this video. And then factoring a perfect square and a difference of square, check these videos. Okay, but all these videos are related to this. Okay, so I'm going to go through some of this. So there's no video, I'm just going to be just explaining. So let's just go through that way. Okay, so okay, what happened there? I didn't mean to do that. Okay, hold on. Go back. Okay, let's see if I can just go like this. Then it's probably easier. So like this. Okay, so this one here, showing 1 and 2. My bad. Give me a second here. Showing day 2. So give me a second. I think I clicked on the wrong one. There's 2. Yeah, there's 2 handouts there. So let me go back. Yeah, 4.1. I want to start off with that 4.1. So let's do that one first. So 4.1. It's loading up. Okay, so you guys should remember FOIL method. I hope you guys do. Okay, where you have when you're multiplying two binomials, you follow this method where the first terms multiply each other. So first times first, then the outers, and then the inners, and then the last. Okay, so when you do that, and basically that is the way you would do the FOIL method. Okay, so now here is on this side here, just a different, just reviewing of saying a perfect square. So a perfect square is what we saw in the last video where you had, when you're doing completing the square, to make it, when you're going from a standard form quadratic to a vertex form quadratic, you have to complete the square. So here, this is what we're looking at. So here are the rules here. And then here's the rules for difference of square, okay? So I guess what it's saying is circle of factors you could simplify using special products. So ones you can specify using the special products, these are the special products here. So this one here is x plus 4 times x minus 4. That one there is a difference of square. So it'd be this one here. So if you saw something like this, I would automatically say, well, x squared is going to be my first term. And my second term would be 4 times negative 4 would be negative 16. Okay. Let's see. This other one here is a perfect square. So what does that mean? Well, I have a perfect square x plus 8 and it's squared. So the perfect square would mean that my first term is going to be x squared. My second term is going to be 8 doubled and times x, which is 16x. And then my last term is going to be 8 times 8, which is 64. Okay. And then this last one here, this one here is a difference of square. You can see here. So difference of square, you go back to here, you can see a difference of square means the first term, it's multiplied itself. So 4x times 4x is 16x squared. That's what you got there. And the last term is going to be negative times a positive, which is going to be squared, so negative y squared, okay? So here are examples of doing more FOIL methods, right? So first term multiply, then outer, then inner, then last. And then you get your first line, and then you simplify the 2 terms there. So negative x plus 4x gives you plus 3x, okay? More examples over here of using the FOIL method. This one didn't have a number in front of x. Now this one, this one does, but you still do the same thing. So it'd be 6x times 2x gives you 12x squared, okay? So you could keep on doing the process of multiplying everything out, and then you simplify. Now this one over here, number 3, is a little bit more complicated. You can see here, because I have a perfect square here, and then I have FOIL method that I have to apply over here. So the first line, basically what I would do is I would deal with the perfect square. So that means I would have the 9, 3 times x times 3x times 3x gives you 9x squared, and then the middle terms, So what you're looking at is a perfect square. So I would have my first term would be 9x. My second term would be the double of those two, so it'd be 12x. And then my last term is going to be 4. So the last term is just 4. So that's what you got there. And over here, you just do the FOIL method. Now I have my numbers outside the bracket. Keep those numbers outside the bracket until the very end. Don't start multiplying inside, you'll get confusion. So now once I have my inside bracket, all the terms all simplified, then I can multiply with inside the bracket, right? Using distributive law. So it'll be 2 times 9x, which is 18x squared. 2 times 12, negative 12x is negative 24x. 2 times 4 is 8. Over here is negative 3 times x squared, which is negative 3x squared. Negative 3 times plus 4x is going to be negative 12x, and then negative 3 times negative 5 is 15. Okay, so then you do simplifying, and that's what you get. Okay, here is the same thing. The only thing here is they want, because you know it's a difference of square, you can use the FOIL method. You will never be wrong if you use the FOIL method. Okay, the FOIL method will still work, but just because you know the difference of square, you can take a shortcut. I'm going to say, well, right off the bat is difference of square. My first term is going to be 6x times 6x, which would be 36x squared. And my last term is going to be 5 times 5, and I have a negative. So it would be negative 25. Okay, that's just shortcuts, but you can still use the FOIL method, it will still work. So now we're looking at common factoring. Basically, when we look at common factoring, what's the biggest number that can go at each of these terms that can divide into each of these terms? And I put that number outside the bracket. Well, in this case here, the biggest number that can divide in this example is negative 3. And the only reason why I'm saying negative 3 is I want to get rid of the negative that's on the first term. So if you can, you would divide it by a negative. So here, my final answer would be negative 3 bracket 3x minus 1. Okay, that's basically getting a common factor. This one here is a little bit different, but to get the common factor, you basically want to get the term, the coefficient that can go into each of these. The biggest number that can go into each of these is 2. Okay, I got my 2. And then what are the variables that's in each? So basically, if I look at the x, what's the biggest, not the biggest, I would say the smallest variable that can go into all of these, or the biggest variable. So x can go into x, right? But x can go into 4, yes, x can go into 3. But if I say x to the power of 4, x to the power of 4 can't go into x, it's too big. So my lowest x value is going to be x, and then my lowest y can fit into all of the terms would be y squared. Okay, so outside the bracket, I'm going to have 2x y squared. That means each of these terms is going to be divided by 2xy squared. And then you need to know your exponent rules when you're dividing variables. Okay, so when you come down to that, you get to this answer here. Okay, how do you get this answer? Well, I divide 2 into there. I got 2. And then I divide x into x. X divided by x is just 1, because anything divided by itself is just 1. So I don't have to put a 1 there. And then y cubed divided by y to the power of 2. Well, that means I'm subtracting the exponents. So I just have y then. Same for the middle one. It's 10. 10 divided by 2 is 5. And then x to the power of 4 divided by x. Well, I subtract. There's an invisible 1 when you have an x, right? It's an invisible 1 exponent. You never write to the exponent 1, but you know it's a 1 there. So you're going to subtract the exponents, so I'm going to have a 3. And then over here, I'm going to do the same thing for each of them, and I get final answer is what you see there. Okay, so that's common factoring. So let's go on to the next example. So I think we covered everything, but it's just more of the same. Okay, So identify which of the followings do you have to factor the long way? Okay. Where A is not 1 and can't be factored out. So A is not a 1 over here. And when we say A, this is what we're talking about. Here's A. A in front of the X squared and B in front of the X, and then the last term is a C. So we're looking at A not being a 1. So this one here, you have to factor out the long way. This one here. And this one. And we say factor out the long way because after we take it out, we cannot do common factoring. And there's no perfect square. And there's no product or sum rule you can use for each of these, because like if you take out, if I look at 29, what goes into 29? Nothing. What goes into 7? Nothing. What goes into 5? Nothing. So these ones right away, they're going to be a trickier way to factor. Okay. So in that case, we have to do something different. Okay. So when factoring something like this, where A is 1 and it cannot be factored out, right? So when we look at this, we couldn't factor out the A. So 2 cannot come out of the 7, 6 can't come out of the 29, and then 4 can't come out of the 5. So you have to factor it a different way. And this is the different way that we have to do. So we're going to look at it like this. So look at the first term. Okay. This is fine. This is an easy one. We can do sum and product rule here, right? And even then, the sum and product rule, you can see two numbers that add up to negative 10, and two numbers when you multiply it together, it gives you 25. Well, we know it's going to be a negative, it's going to be a negative 5, right? Negative 5 times negative 5 gives you a plus 25, and then a negative 5 added them together gives you a minus 10. So this is a perfect square, okay? That's easier enough. And this one, same kind of thing. It's kind of easy where you can say, well, two numbers that add up to 15, and then two numbers when you multiply give you 56. Well, those two numbers are 8 and 7. Okay, and then you have x plus 8, x plus 7. Okay, that's not that bad. Okay, here's a little bit tricky one. Well, I can factor out the 3. So once I factor out the 3, then I can just use the sum and product rule to get the factor of what's inside here, right? So two numbers that add up to 6, and then two numbers that multiply together to give you 8. Well, two numbers that multiply together to give me 8 are 4 times 2, and then you add them together, they also give you 6. So that's what you get there, okay? So now, so this one here, you could factor out the A. You could factor out the number in front of the X out of each of these terms, right? Now we get situations where you cannot do that. So, so the things you need to look at first is look to see if there's a common factor that can be divided out. Take the A value and multiply it into the C, and then determine the factors of this number and add them together to give you the B value. Okay, so we're gonna go through this step, okay? Here we go. Here's the first example here. When I look at this one here, I can't factor out that 2. 2 does not go into 5. Okay, it does not work. So what we want to do now is do the first step where I'm going to multiply the 2 times the A times the C, right? And then I'm going to have a number is equal to 4. So my product is 4 and my sum is 5. So two numbers that multiply to 4 and then two numbers that add up to 5. Okay, so that's the first step. So that's what we did there. Okay, so like I said here, you can see it. I'm just going back again here. Take the number A value and multiply it to C. That's what I did here. That 2 is the A, this 2 is the C, multiply it together. And then I got 4. Now I got to figure out two numbers that add up to 4, and then two numbers that add up to the 5 there, or two, sorry, two numbers that multiply to give you 4, and two numbers that add up to 5. And we worked it out that it's going to be 1 and 4. So now since it's 1 and 4, we plug it in here, and now we have 1y plus 4y. So we need to now do grouping. So we're going to do grouping factor by grouping. Okay. So what that means is it's going to put a bracket in front of each of them, like I did here. And now someone's going to say, well, why don't I put the 4y with the 2y squared, or the 1y with the 2? It doesn't matter which way you put it. Okay, repeat, it doesn't matter. Okay, in the end, it'll work out. If you did everything here correctly, it will work out, doesn't matter. So we're going to say the 1y goes with the 2y squared and the 4y with the plus 2. Okay, now you want to factor out the common factor for this term. Well, y can go into both of these terms. So I have y in front of the bracket, then I'm going to divide out each term by y. Okay, and if I divide out each term by y, I'm left with 2y. I don't know what happened there, but basically I'm left with 2y plus 1. Now over here, okay, what number I can divide out from each of these terms? I can divide out 2. So I'm going to have 2 here. So 4y divided by 2, and then 2 divided by 2. So I'm left with, it's not actually showing. I'm going to write it here because I don't know why it's not doing that. I'm going to do it in red so you can see. Over here, I'm left with 2y and then plus 1, okay? Over here, I'm left with, when I divide out, I'm left with 2y plus 1, okay? So I have here 2y bracket 2y. So if I rewrite it with the bracket, so it'll be a y in front of it. And I rewrite this with a bracket, plus 2. That's the step that's not showing. I don't know why it's not showing. Now, when I am, now when I want to do the factoring, well, what I'm left with is factor these out. In both these terms, I have 2y plus 1. So here's 2y plus 1, and then I'm left with y plus 2. Okay, so this is my answer right there. Okay. So this is the factor for the answer up there. Okay. So this question here, I do the same thing. Okay. I multiplied my 4 times my 9. 4 times 9 is 36. The two numbers that add up to multiply to give me 36, and two numbers that add together gives me negative 12. So two numbers that multiply together gives me 36. And when you add them together, gives me negative 12. Well, here, negative 6 and negative 6 gives me negative 12. And when you multiply negative 6 times negative 6 gives me plus 36. So you go through the same process here, which you did, where you're going to do now the grouping, okay? And then you factor out in the groups, like we show you there. And then you should divide each one out, okay? And then I don't know why you scratched that. That's actually correct, right? So 2x, and then over here you're gonna have 2x minus 3, okay? And then over here it'd be, when you take that out, be negative 3, so negative 2. So not negatives, because you're dividing by negative. So it'll be 2x plus negative 3. So I'm left with the factors of 2x minus 3 on one bracket, and then the other bracket would be 2x minus 3. Oh, wow, they're both the same. So you know what that means? It's a perfect square. So that's what you do there, okay? So that is what is covered. And I believe we covered all the different scenarios of how to simplify equations, okay? So to simplify equations, there's common factoring. There is difference of squares, factor by grouping that we just did here. Okay, so let me come out of this, go back to here. So different scenarios that was done here. So now, if you want, you can go into, if you need some more, the video, if what I'm saying is not enough, you want to go check out some more videos, here are the videos. It's like I said here. Factor by, well, here, just adding subtracting polynomials together, which we kind of did that anyways. That's like collecting like terms, right? FOIL method, we talked about. Common factoring, we just did. Factor by grouping, or sorry, completing the square. Did we talk about completing the square? I think difference of squares and perfect square and factoring complex trinomials. So factoring complex trinomials is what we just did, which is completing the square. And then basically when you can't divide the A into each of the terms, you have to multiply the A times the C. And then from there, you go through the process of figuring it out. Okay, so when we go to here, this is the questions, practice worksheets you should do here. Like I said, you need to do these practice questions. If you just jump into doing the quiz, you will not do well if you didn't practice, okay? And like I said, once you do the practice questions, I will give you the step-by-step instructions. So let's look at the worksheet. Let's look at each of the worksheets. So let's look at this worksheet is for the inverse. Let's look at that one. Go to it. So we click on that. What does that one look like? Okay, so here, inverse. So you're going to go through each of these questions, sketch the graph of the inverse of the function. Okay. Okay, and then it's asking a question, is the inverse actual a function? Right, and we know using the line test, you can tell, okay? Here, determine the equation of the, so this is where you swap the X and Y, okay? So you can do those questions. Okay, again, same thing, swapping the X and Y. The same, determine the equation of the inverse. You will see that in multiple choice. So if you get a question, you'll see questions like this in multiple choice. Again, this one's saying determine the inverse function. Okay. Like I said, with this one here, it's easier to first, you can turn that into vertex form. Like we said, turn it into vertex form, like I said earlier in the video. And then because you have only one Y to deal with. If you try to isolate it here, that means I have Y in two spots here, and it's going to be hard to isolate Y. I have a Y in a square, and I have a Y times the number. It's too hard to isolate. That's why I want to make sure you turn this into vertex form first. Okay, turn it into vertex form, then do the swapping the X and Y. Otherwise, it'd be too difficult. Okay, determine if the relations shown are inverse of each other. You can determine it by maybe looking at the equation. Okay, look at the equation, convert the equation, you can do that. Same thing here. Okay, and continue. And I believe the answers are over here. Okay, so you can look at the answers. And if you need step-by-step, well, I'll be sending you the step-by-step solutions after you submit this. Okay, so we did that one. So let's look at the next one, which is simplifying. So let's look at that. Here, simplifying. So we're looking at simplifying. Here is worksheet on simplifying polynomials. So here you go. So here's a bunch of polynomials. You can see here's multiplying polynomials. Okay. Here is common factoring in polynomials. Okay. Here is factoring where A cannot be factored out. Okay, and we went through that process. Here are special products. So here's a perfect squares. You can do that. Difference of squares on this side here. Here's an application question. Okay, and here are the answers. Okay. Do the practice questions first. Please do the practice questions first. If you just, and maybe, you know, some of these it's a lot. So maybe I would accept, you don't have to do every single one of these. Maybe I would do like every other one just to get the practice in, and maybe I'll do one of the hard ones. Okay, that's would be my suggestion. Not, you don't have to do every single one, but I would do all the hard ones. Right, start off with some easy ones and then some hard ones. And remember the answer at the back. Okay, and then I can send you the step-by-step solutions for this. Okay, so let me see here. So that is basically it. And there would be a quiz. If I click on here, I'm not sure the quiz is showing. The quiz is going to actually show around, yeah, it's not showing yet. It's going to show about 9:30, I believe. And again, if you rush into doing the quiz, you don't want to do that. Like I said, like when I looked at the previous day's quizzes, a lot of you guys did well, right? I didn't see anyone that got 1 out of 3, right? So again, 1 out of 3 means you got 33%. So it's going to be the same kind of format, 3 questions, right? So if you do 3 questions, and it's randomized, I'll tell you this right now, it's randomized. So you know, you don't know who's going to get what question. It's random. It's not the same question for every student. Every student will have a different type of question, but it'll be similar. Okay. So don't try to be, I'm going to ask my friend, what's that question? What was the answer? If he wants to help you, I don't think he would, but, or she, but don't do that again. Okay. So please do the quizzes on your own, but again, do the worksheet first because you're ready for the quiz. Quiz counts into your final. Worksheet does count indirectly. So I'd also say you do that too, okay? Don't skip it and then go directly to the quiz and you bomb the quiz. And you didn't even do the worksheet. So you got nothing on both sides. So don't do that, okay? So that is it for today. And tomorrow I'll see you guys, which would be Wednesday. I'll see you guys live on Wednesday. Okay. Okay, so that is it for today, which would be July 5th, Tuesday. Thank you again, guys. Bye.